Okay, hello everyone, this is Miss Martinez. We're going to go over 7.K7.2, how to factor quadratics. So let's first look at the definition of factoring and what exactly this means. So to factor means that we are finding the factors of the standard form trinomial that help us solve for the zeros. Okay, so remember our standard form of quadratic functions right here is a trinomial. Right here, ax squared plus bx plus c. So it has three terms, that makes it a trinomial. And so if you remember from multiplying polynomials, factored form is made up of two binomials multiplied together here. That ax minus p here, and then this x minus q, that is a binomial. Times a binomial. And if you remember from multiplying, that always results in a trinomial. Okay. So when you multiply that through, we get a trinomial. So both of those binomials are called factors, okay? A factor are two numbers or expressions that multiply together to give you another number. So let's do two binomials that multiply to a trinomial. Okay, and so if you also remember from last week's video, factored form shows us our zeros as well within those binomials. So within this process, it's going to help us solve for the zeros algebraically. Okay, so what we're going to do is look at these two standard form quadratic functions. The first one here is x squared plus 5x plus 6. And we're going to use these area boxes again to help us pretty much go from standard form to factored form. Okay, so this is like this is your start in standard form, and then we finish in factored form. That's the goal. Okay, so we're going to place the pieces of this standard form trinomial inside the box where we know they go from whenever we multiplied using area models. So remember that x squared always goes in that top left box there. And then that plus 6 at the end, the constant term, always ends up in this bottom right box there. So we know those two pieces. Okay, because remember what's inside the box is the trinomial. That's all of those little squares added together gives us this final expression. Okay, so remember that the 5x here, that middle term, the x term, that comes from adding these two boxes together. Okay, so we need to come up with some numbers here that are going to add up to 5x in those two boxes, but also those two numbers are going to have to multiply to the 6. Okay, this is what's going to help us get our factors here that go on the top. So I know that x times x here is the only way to get x squared. What I need to figure out is what's going to go here. What times what gives me 6 for that bottom left area, bottom right area. But then also those two numbers are going to need to add to these two boxes here. Okay, so some factors of 6, I would say, are 6 and 1, but 6 plus 1 does not give me 5. So let's go to the next two that we know, like 3 and 2. 3 times 2 is 6. And then let's check if it adds to 5. 3 plus 2 is also 5. So that is going to work for us. So if I put a plus 3 here, and then a plus 2 here, the area for this top right box would be 3x, because 3 times x is 3x, and then 2 times x is 2x. Add those together, I get 5x, okay? And so that's how you check. Whatever's inside the box must add up to your original standard form at the top there. So it does. And we have found the two expressions that multiply to give us that answer. These are your factors here. This and this. These are your factors. Okay, so now we're going to write the equation in factored form like it is here, just the binomial times the binomial. A is 1. We know that because we just have an x squared here. There's just a 1 right there that's implied. So our factored form is going to be f of x equals x plus 3 times x plus 2. Okay, so we just factored the quadratic function and rewrote it from standard form into factored form. Okay, let's do the second one. F of x equals x squared minus 2x minus 8. So again, fill in the standard form pieces of the trinomial inside the box of where you know they go. So x squared here, and then that constant term at the end in that bottom right box. That's a negative 8, so don't forget to write negative 8 and not a positive 8. Okay, and then we can kind of start filling out the parts of the binomials that we know. We just always know right off the bat that x times x gives us x squared. So that's our length and width for that first box. So our constant is negative 8 at the end. So we know that this number times this number has to give us negative 8. But also these two boxes in the the diagonal boxes here, these have to add up to that negative 2x. So I need numbers that multiply to negative 8, but add to negative 2. Okay, so things that multiply to negative 8, we've got negative 1 and positive 1. So here, because we've got negatives this time, we know that at least one of the numbers must be negative. Negative 8 and 1, that's not going to add to negative 2. So let's move on from 8 and 1. Let's try 4 and 2. Okay, so what if we did... well, we know that 4 times negative 2 equals negative 8. But does 4 minus 2 equal negative 8? No. Okay, so that means we need to switch which one's negative. So why don't we try the negative 4? The 4 as negative, and then the 2 as positive. So we know negative 4 times 2 is negative 8. And then let's do negative 4 plus 2. And then we get a negative 2 there. Okay, so negative 4 and 2 are our magic numbers. That's what's going to go here and here. Okay, 2 times negative 4 gives me that area of the bottom right as negative 8. And then let's fill in the rest of these. So x times negative 4 is going to be negative 4x here. And then 2 times x will be 2x. And then when I add those up, negative 4x plus 2x, when I simplify, that gives me that negative 2x there in the center. Okay, so we have factored that trinomial into 2 binomials. So let's go ahead and write this in factored form now. This would be f of x equals x minus 4 times x plus 2. Right, since that's a positive 2, remember that's a plus there. Okay, so these are just 2 different ways to write the same function. The standard form that we started with, this is the exact same function as this equation we just wrote down here in factored form. If I were to multiply these 2 binomials right now, I would get that standard form equation. That would be my answer. So basically, we kind of went backwards from what we had learned a couple weeks ago with multiplying. Okay, now how does this help us find the zeros? Okay, so let's kind of talk about this. So remember, our zeros, we also call them solutions or x-intercepts or also roots. Those are all 4 names that you will see for those. And we can get these once we've factored, okay? So we're going to find the value or values of x that make the equation true. And when we do that, we're going to solve for those zeros. Okay, we're just going to do this for the second one, and I'm going to write my steps off to the side here. So let's call this number 2. And we're going to do number 2 here. Okay, so the first thing to do, remember that your zeros are when f of x equals 0, right? That y value must be 0 in order for it to cross the x-axis. So maybe make a note of that, f of x equals 0. So our first step is to replace f of x with 0. Okay, so we're doing this from factored form. So instead of f of x equals, I'm going to do 0 equals. X minus 4 times x plus 2. Okay, so now this is an equation equal to 0, and this is showing that basically one number times another number equals 0. Well, there's only one way for that to happen. Remember, in order for something to be multiplied together and equal 0, one of these binomials must be equal to 0. Okay, so that's going to help us with our step 2. Since one of them must be equal to 0, we're going to actually set both of them equal to 0. So set each binomial or factor equal to 0. Okay, so this is step 2. So basically you're just going to write 2 little equations here. So I'm going to take this x minus 4 binomial and I'm going to set it equal to 0. And then I'm going to take the other one, x plus 2, and also set it equal to 0. Okay, and then step 3 is you solve for x. Solve each equation for x. Okay, super quick from here, just one step. Do your opposite operation, add 4 to get x by itself. So x equals 4 on that one. Subtract 2 here. X equals -2. So these give us the x values of our zeros. So our zeros would be, sorry, that was step 3. So our zeros are 4, 0, written as a coordinate, and -2, 0. Okay, that's where this function crosses the x-axis.